have done the same practical. In that practical, we have considered the sample as a water sample, but this time we are going to use the sewage sample. Okay, this is the sewage sample which we have collected from the cart road. Okay, so today we are going to perform the determination of chloride. So for the determination of chloride, as you know, we require two things. First is the titrant, and second one is the indicator. The titrant which we are going to use is the AgNO3. AgNO3 is nothing but a silver nitrate, and second one is the potassium chromate. I am just going to show you what are the apparatus which is going to require, what are the chemicals and the indicator which we are going to require. So first chemical which we required is the AgNO3. AgNO3 is what? Silver nitrate. And this silver nitrate we are going to use as a titrant. So we poured it in this burette. In this burette we pour it till it become 0. You can see here, right? Next is indicator. Which indicator we are going to use? We are going to use this potassium chromate. So the color of potassium chromate is yellowish. You can see over here. This is how it looks like. It looks totally like a salt, but difference is the color. Salt is of white color and this one is the yellow color. Next, we require a conical flask over here. Next is the measuring cylinder so that we can measure the sample. And last is the sewage sample. So we are going to take this sewage sample in this beaker. Okay, so this is the sewage sample which we have collected from the cart road. Okay, you can see over there. This is the sewage sample which we have collected. Okay, so let's see the procedure of it. First of all, what we have to do? First we have take the AgNO3, and this AgNO3 we have poured in this burette. You can see here we have keep it up to 0 marking. You can see over here, right? Next we have to take a sample. So how much amount of sample we are going to take? We are going to take a 10 ml of sample. You can see here this is the sewage sample we are taking, and we have to pour it till 10 ml. Right, you can see that. Now that we have taken the 10 ml of sample. Now what we have to do with this 10 ml of sample? This 10 ml of sample need to be poured out into this conical flask. Right, done. Next step is to take this indicator. What is this indicator? This is potassium chromate. And what is the formula of it? K2CrO4. Now that we are going to take a pinch of potassium chromate. So how much amount of potassium chromate required? According to the sample we have taken. If we have taken the huge large amount of sample, then we have to take the huge quantity of potassium chromate. Now we have to take the pinch of potassium chromate into this water sample. Now that we are going to pour this in the water sample. Next is we have to mix it thoroughly. Right? Now that we are mixing this, as soon as we mix, the color changes to yellow color. Now what we have to do? We have to titrate it against this AgNO3 till the color changes to yellow to brick red color. Now we are going to titrate it against AgNO3. Now you can see that as we pouring out the drop, the color changes to red color. But do we have to stop here? No. We have to do it till it becomes totally brick red color. Okay. Now that we are doing this drop by drop, you can see over here. It starts from 0. Now 1 ml, 2 ml. Okay. We are pouring the sample. You can see that the color is changing to red. Now the color is totally changes to brick red color. So now what is the next step? Next step is to check how much amount of AgNO3 is being required in this. You can see over here we required 3.9 ml, right? You can see over here this is 3, this is 4, and in between this is one line. Okay, how much amount of AgNO3 we required? We required 3.9 ml of AgNO3 for the titration purpose. Okay, so now to determine the chloride content, what is the formula? Formula is C multiplied by normality Normality of what? Normality of AgNO3. So whatever the guideline we have taken, we have to take the normality of it. Next is the equivalent weight of chloride. Now that we are calculating this chloride, that's why equivalent weight of chloride is nothing but 35.5. Multiply by 1000 to just convert the value, divided by volume of sample. So what is the answer we get? How much is the AgNO3 required? It is nothing but 8.9 ml. Multiply by normality of AgNO3. Normality is 0.025. Multiply by 35.5 into 1000 divided by volume of sample. How much volume of sample we have taken? We have taken the 10 ml of sample. Right? After calculation, you have to tell me how much amount of what is the chloride in mg per liter. So students, what is the final answer we get? We get the answer 346.1. Okay, that's the chloride content in our sewage sample, right? So this is how we have to perform the practical for the determination of chloride of a sewage sample. When we do the same practical as far as water is concerned, so how much amount of chloride we get? We get the 0 mg per liter. Remember this, 0 mg per liter. We don't get any kind of chloride in a drinking water, and we don't require any kind of water. Even though the permissible value is 250 mg per liter, let me just show you. Okay, so you can see in this chart, what is this chart? The test characteristics for drinking water as per IS 10-500-2012. You can see over here, this is the 15 number, this is chloride. So chloride, how much do we require? The acceptable limit is 250 mg per liter, and the permissible limit in the absence of alternate source is 1000 mg per liter. It is okay if we get the 250 mg per up to 250 mg per liter as far as drinking water is concerned. But now what we have done, we have taken this sewage sample. So in sewage sample we might get different amount of chloride content in water. So this is the whole practical procedure how to determine the chloride content. Hope you understand this practical very clearly. If you have any question, you can ask me anytime. Okay.